these leaves are heavy today.
Yes, we have a good yield.
From the fields where it's carefully harvested by hand, the aloe vera is quickly transported to our state-of-the-art facility for processing.
Heads up, coming through.
Got it. Move it to the belt.
This batch looks good. Proceed to slicing.
As you can see, the levels of zinc and magnesium are significantly high.
Yes, the trace element analysis confirms the purity of the sample.
The analysis is complete. Purity levels are stable.
Flow rate looks consistent across all vats.
Increase the flow rate by 5%.
Noted. The aloe sample in compartment 3 is showing rapid growth.
The spent material is separated here, allowing us to analyze the efficiency of the extraction process shown on the monitors.
The viscosity is much higher than the last batch.
Yes, and the color stabilization is excellent. Look at this clarity. Look at this.
According to the sensor, the pH is exactly 6.2.
Good, that aligns with the target range on the tablet.
This discoloration indicates contamination. We need to discard this leaf.
Agreed. Ensure it goes into the red bin.
Make sure the labels are facing out on these gels.
Got it, thanks.
That's the last pallet for aisle 4.
Good, my arms are starting to feel like jelly.
The data confirms the viscosity is optimal.
Keep the flow rate steady, and I'll monitor the temperature here.
We need to maintain the agitation rate. The viscosity is holding steady at 2400 centipoise, which is exactly what we want for this batch.
The manual addition is complete. Monitor the reaction.
Levels are steady. Switching to automated feed now.
The pressure needs to stabilize before we increase the flow rate.
Noted.
The pressure is stabilizing right at the target level.
Noted. The viscosity seems high.
This one is properly sealed. The label application is centered correctly.
The suspension quality is excellent right here. Here.
And the viscosity levels are stable.
We should recheck the pH on the milky sample.
Agreed. It seems slightly unstable compared to the control.
The pH level is slightly off here. We need to adjust the concentration.
The viscosity is stable, but the thermal reading is spiking.
As you can see, the molecular weight distribution correlates directly with the extraction temperature.
Right, so we maintain the current parameters for the next run.
As you can see, this batch shows significantly higher polysaccharide levels.
And the data on the chart confirms that stability.
The polysaccharide content is consistent across these samples.
Yes, and the viscosity of this batch looks promising.
Flow rate is optimized now.
But we still have an intermittent fault on the conveyor motor.
Let me test the input voltage here.
We need to reroute this yellow wire according to the updated schematic. Okay, I see where it goes now.
The volumetric analysis shows a slight deviation at the 5th nozzle.
Noted. Rerunning the calibration sequence immediately.
Calibration complete. Check the flow rate on line 3.
Confirmed. Everything is nominal.
The steam release valve is activating too frequently. We should inspect the connector before the next batch run.
Pressure is still critical.
Check the flow rate on line 3.
Capping torque seems stable now.
Everything looks stable here. Record the gauge pressure.
Got it. Looks good.
Keep it moving. Watch the conveyor.
All right, easy on the brake now.